Hey guys, this is Miss Van Tassel. So I'm going to be uploading videos to help you. I know that some of you are really struggling with some of these units, and so sometimes it's easier to just hear somebody kind of talk out the notes or work out the notes with you. So I'm just going to pre-warn you that in this particular section there was a lot of vocab, so the beginning is going to be a lot of vocab and just me talking, and then we'll work through some problems. And so I want to start with sampling distributions and just some vocab that goes with it. A census. So basically a census is just data that's collected from an entire population. This year we're actually doing a census for the United States, so you've probably heard on the radio those advertisements where they're like, send in your census, and that's because they just want information from every individual or from every household. So because it involves every household in America, that's a census. Now, if it only went to some of the households in America, that would be a survey. Population is the group being studied, the whole group. So, for example, if I'm studying the households in America, all of the households in America are my population. On the other hand, a sample would just be a portion of the population. So maybe I'm studying all of the households, but it costs a lot of money to gather information from every single household. So instead, maybe I'm just going to gather information from like 10 households in every state. That would be a sample. A parameter is a characteristic of the entire population. So like the mean of the entire population of households, that would be an example of a parameter. The median's a parameter. Mode is a parameter. So all of those things are parameters. A statistic is a characteristic of just your sample, and we use statistics to estimate information about our population parameters. Okay, so those are the difference in each of those words. We're also going to be dealing specifically in this section on population proportions, and so we do use P for that notation. And then there's a sample proportion. So a sample proportion, we also use a P, but we want to make sure that we can just note the difference, and so they put this little arrow thing above the P, and so they also call that P hat. So you can see it, sometimes they'll refer to it as like this, or sometimes they might write P hat, but it's the same thing. And so what that is it's going to be whatever you're looking for. So maybe if you're asking, like your survey is asking yes and no questions, the proportion of your yeses would be how many yeses. So the X is what you're looking for, and then over your total amount of like data or surveys that you have. So that's what the N is your amount of samples. Variability. Variability looks at the spread of your data. So like how consistent is your data. So variability has nothing to do with how accurate your statistic is, but it has everything to do with how accurate your data is, or how close it is to the actual amount. But variability is looking at like how consistent those data pieces are. So are your data really tight and close together, or are they very spread out? Bias and unbiased, those look at the accuracy of your statistics. So like how accurate is your data to the actual value. A normal distribution. So normal distribution follows this, they call it a bell-shaped curve. That's also called a normal curve. What you'll notice about the bell-shaped curve or the normal curve is that I don't know why I put quotes around that. Okay, so it's symmetrical. The mound, so most of the data is in the middle. and the mean is actually directly in the middle. So 50% of your data is below the mean, and 50% of your data is above the mean. So some pieces that we use, or the biggest piece that we use to measure variability, is standard deviation. So how spread out is your data? Okay, so when can I use a normal distribution, or when can I assume it's a normal distribution? When we're dealing with proportions. And so there's a couple rules when you're dealing with proportions before you can assume that you're using a normal distribution. The first is that your population, so the total population of whatever you're studying, so I'm going to use that same example of households. So let's say I pulled 2 households in each state. If I pulled 2 households in each state, and so if my N is 100, then 10 times 100 would give me 1,000. And is my population bigger? We know that the population of households in America, so all of the households in America are definitely bigger than 1,000. So check that criteria is complete. For the second criteria, the number of samples times your proportion has to be greater than or equal to 10. And so I would need to take my 100 samples and times them by whatever my proportion is. I don't even have a number, but that would have to be greater than or equal to 10. And then number 3 is very similar to the last one, except so they use 1 minus p. 1 minus p is the same thing as the proportion that's not p. Sometimes they'll also use q. I've seen them use that in situations before also. But if the number of samples times 1 minus p is greater than or equal to 10, then that's your third criteria. So then yes, you can use a normal distribution. So those are the 3 things that we want to be checking for. So criteria for normal distribution. Okay, so what does this mean for us? What this means for us is if we can use a normal distribution, that means that the mean of the sample proportion so that mu symbol stands for mean. So the mean of the sample proportion is equal to the population proportion. So we can go ahead and just assume that they're equal. The next is the standard deviation. So the standard deviation of the sample proportion is going to equal the square root of p times 1 minus p over n. And so this sigma notation means the standard deviation of sample proportion. And so we can go ahead and assume those things as long as our other criteria has been met. So let's look at an example of this. It says the true proportion of sweeties with the message "Be Mine" is 24%. You purchase a small box of 50 candies and find that only 10 of the 50 candies say "Be Mine." Can we use a normal approximation? well, we need to check our criteria. So our first criteria is that our population has to be bigger than 10n. And so n in this case is our sample size, which is 50. And so our population of candy hearts has to be bigger than 10 times 50, 500. And so I would say, yeah, there's definitely more than 500 little candy hearts. And so then for part B, we also need to prove that 10 times our proportion. Nope, that's wrong. Go back. Okay, sorry. N times our proportion is greater than or equal to 10. And so remember, our N is 50. Our proportion is our 24%. So 0.24. And so we get 12 is greater than or equal to 10. So check, check. And then our third check is that N times the proportion of not P, which is 1 minus P, has to be greater than or equal to 10. I've also seen them use Q for this as well. And so that would be 50. And then, so if the proportion of P is 0.24, then the proportion of not P would be 0.76. And so we already know that if 50 times 0.24 is bigger than 12, then 50 times 0.76, is bigger than 10, then 50 times 0.76 is going to be greater than or equal to 10. But I'm going to go ahead and go through it anyways. So we get 38 is greater than or equal to 10. So check. Okay, so now that I know I can use a normal approximation. So part 2, it says, what is the mean of the sampling distribution of P hat? So I'm looking for the mean of the sampling distribution of P hat. And so the mean for that, we already said that it was a normal distribution. So it's just going to be whatever P was. And so going back to our problem, it says that the true proportion of sweeties is 24%. And so my P is 0.24. So the mean of P hat is 0.24. Find the standard deviation of the sampling distribution, and so I'm going to use that formula for standard deviation. So standard deviation of P hat is equal to the square root of P times 1 minus P over N. And so we have 0.24, 0.76. These two numbers are always going to add up to 1, just to kind of help you out there. It just makes it go a little bit faster. And then over 50, and then I'm going to plug this right into my calculator. And I end up with 0.0603. Actually, I don't. I'm going to round. Sorry, 0.4. Okay. All right, and then it says, how would you describe the sampling distribution? Well, we already said that we're going to assume that it's a normal distribution because it meets all the criteria. With a mean of 0.24 and a standard deviation of 0.604. Okay, so the next piece of this, it says part 2, what is the probability of getting 10 or fewer sweeties with the message "Be mine" in a box of 50 candies? And so in order to find this, we're going to use our z-score. And so you guys should have gone over z-scores. In fact, I know that you did, but I'm just going to kind of review it real quick. So to find your z-score, for these, you're going to do p hat minus your population proportion over your population standard deviation. And so the probability of getting less than or equal to 10 is what I'm looking for. And so if that's what I'm looking for, then my p hat is going to be 10. My p is 0.24 still, so this is still from the last part. And then we found our standard deviation already, so I'm going to go back and look at that. So 0. Okay, oops. That shouldn't be there. Okay, so what is the probability of getting 10 or fewer sweeties with the message "Be mine" in a box of 50 candies? And so for this, I'm going to be using my standard normal table. So I'm going to be using a z statistic or a z stat. And so the z stat formula is p hat minus p over our standard deviation. It's very similar, well, it's almost the same thing really as when you did like the sample mean minus the population mean over the standard deviation. It's really the same like concept. And so our p we already know from before is 0.24, and our standard deviation from before is 0.0604. And then our p hat is going to be what we're looking for. So we're looking for the probability of getting less than or equal to 10 out of the 50 candies. So my proportion of what I'm looking for is 10 over 50 or 0.2. And so my z-stat is going to equal 0.2 minus 0.24 over 0.064. Nope. 0.604. And so I'm going to plug that into my calculator. All right, and so I get my z-stat is approximately negative 0.6623. Now, to get my probability, which is what I'm looking for, I'm going to have to use a z-table. And so I'm going to actually attach one to this post, but I have one on the next slide. So the way the z-table works is that the rows and columns are your z-score. So that's that number we just found. So we just found negative 0.6623. A couple of ways to check to make sure that you have the right number is that if your sample statistic is less than your population statistic, then your z-score will be negative, and if it's bigger, then your z-score will be positive. And so our z-scores are the rows and the columns, And then the probability is the inside of the chart. Now, the probability that's listed in these is always for less than. So you'll see that it's like the left side of the curve that's shaded in. If you want the right side of the curve, so if you want greater than, you're going to have to take your probability and subtract it from 1, okay? So that's really important. But ours is less than, so we can actually just look at the score itself. So negative 0.6623. So you'll see over here that all my negatives are on the left half. And all my positive z-scores are on the right half. So negative 0.6. So I start in my rows. So I'm looking for negative 0.6, which is right here. And then on the columns, I'm going to look for 6, 2. So it actually only goes to 3. So negative 0.6, and then 6 is in my hundredths place. So I'm going to match up my row and my column. And so it's right there, which is very hard to see, but it looks like it'll look better for you when I send it. I'm going to have to cheat and look at my sheet. 0.2546 is what that number is. And so the probability of getting fewer than 10 out of 50 candies would be about 25.46%. Now for part B, it says, how likely would it be for you to get a box of sweeties with 30 or more candies with the message "Be Mine"? And so I'm going to follow the same steps. My P is still the same, and my standard deviation is still the same. This time my P hat is going to be 30 out of 50, or 3 out of 5, which is 0.6. So my Z stat is going to be 0.6 minus 0.24 over 0.0604. Okay, so I end up with a Z-score of 5.96, and so I'm going to go to my table. Now, 5.96 is a very, very large Z-score. It's like off the charts, so you'll see that 3.4 is really as high as this goes. So if I go to 3.49, it's like 0.9999, so that just goes to show you that it's even further. But remember that this is for less than, so that would be what would be the probability of getting something less than 30. And so for bigger than 30, we would do 1 minus that probability. But we're going to have something much larger than 0.9. So essentially anything above like 4 as a Z-score is going to either give you like 100% if it's less than, or if it's greater than 0. So this is going to be approximately I'm just going to show you actually before I just want to make sure that we understand what happens. So when I found that in my table, I was looking at less than or equal to 30, which was about 1. But I want to know for greater than, so if the probability of it being less than 30 is 1, then the probability of it being bigger than 30 would be 0, because this would mean there's 100% chance of it being less than 30. And so then there would be a 0% chance of it being more than 30. Okay, these videos are only supposed to be 30 minutes, and so I'm running out of time, so I'm going to try to rush through this last part. It says, how many candies with the message "Be Mine" are in 99% of the boxes of candies? And so this time I know my percentage, but I'm just trying to figure out what my proportion would be. So this time I'm looking for P hat. I don't know what it is. That's going to help me figure out how many. So I'm going to go to my Z table. This time, though, I'm looking for the Z score, not the probability. So I'm going to look inside my table to find 99% or 0.99. I want to get as close to it as possible. All right, so let's see. So I know that 0.99 is bigger than 50%, so it's got to be on the right side of the table. And okay, and so that's probably the closest I can get is 0.8997. And so then I go out to my row, so 1.28 is my Z score. And so I know that my Z stat is 1.28. I still have the same P of 0.24. My standard deviation is 0.0604, and so I'm going to set up my formula. So Z stat is equal to P hat minus P over our standard deviation. So 1.28 is equal to P hat minus 0.24 over 0.0604, and so I'm solving for P, so I'm going to multiply both sides by 0.0604. Okay, so I worked out the calculations, so I multiplied by standard deviation, and then to get rid of the negative 0.24, I added 0.24 to both sides, and so I got P hat is equal to that, and so that's my proportion. So that means about 31% or 32% of my 50 candies. So the number of candies that I can make sure I'll get 99% of the time is going to be 0.3173 times 50, so approximately 16 candies. I'm not going to have time to go over the full part D before my video shuts off. So what you're doing is you're going to be looking to find in between two numbers. You're going to find the probability of it being less than 40%. And the probability of it being less than 30%. And so if you're looking for the probability of it being in between these two, you're just going to take this one and subtract this one, and then that should give you your final answer. This was a lot of information, so I hope that it helped. If it didn't help, or if you need more help, I can Zoom meet with you guys. I can put up more examples. Just let me know what you need, okay? And I'll put up some more videos of the upcoming sections.